In part 3 of section 6, we're going to be looking at writing a linear function. So we've discussed what the format of a linear function looks like from the equation perspective, and we've also talked about what a linear function looks like graphically when graphed in the Cartesian coordinate plane. So in this example, 6.4, we're being asked to define a linear function. So when I think about a function, I always think about there being two things that I have to be able to determine. Number one, I would like to be able to determine the equation for the function, and number two, I need to be able to determine the domain for that particular equation, which becomes the domain for my function. So because we have the modifier here of linear, I know that the equation has to be of the form y equals mx plus b. And then also because of the equation y equals mx plus b, since there's no division by zero possible, there's no square rooting going on in this equation, then there would be no restrictions on the domain. So we automatically know that the domain has to be all real numbers. So now I look at the given conditions for writing a linear function. It says define a linear function with slope of -3 that passes through the point 0, -2. So these are conditions. We have condition A and we have condition B, and we have to make sure that both of these conditions are satisfied in order for us to write the appropriate linear function. Now the good news is that for part A, or information A, it says slope of -3. Well, that means m must be equal to -3. So that's already spelled out for us. And then passes through the point 0, -2. So you're going to see this giving of a point, having to pass through a particular point as a particular condition often. That's going to happen a lot. In the event that the point you are given is a y-intercept, if you know that it's a y-intercept, then that means whatever the value is for the y in that ordered pair must represent b. And this does represent a y-intercept. And you can always tell if it's a y-intercept by taking the point and plotting it. If it plots on top of the y-axis, then you know it's a y-intercept. And that's exactly what would happen with this point. So with that said, the equation can now be written as y equals -3x minus 2. So we have the equation, we know what the domain should be. Let's write our function definition. I'm going to choose the name f from R to R, given by f of x is equal to -3x minus 2. And that is the linear function defined with a slope of -3 and passes through the point 0, -2.